Welcome back to Understanding Human Anatomy and our discussion of the peritoneal cavity. This is the 6th video discussing how the peritoneal cavity develops. I'm going to start by drawing a sagittal section through the embryo at about the end of the 6th week, beginning of the 7th week. So we'll start up here, and the top of our diagram will be the diaphragm. And we'll draw the dorsal body wall, then around to the ventral body wall, and back up to the diaphragm. We'll draw in structures of the digestive tract, and we'll put the stomach about in this position. We're going to have the duodenum at this spot, and we'll put in some transverse colon at this point. And then I'll draw in the liver, like so. We'll color it in. Okay, and let's put some labels in here. This is the liver. And we'll move down here, and in the stomach I'm just going to use a capital S and a capital T to indicate stomach. Over here is the duodenum, which will represent with a D. And then here is the transverse colon, which we'll label with a TC. Next, I'll sketch in the peritoneum, so here's parietal peritoneum on the dorsal body wall, and since the duodenum is secondarily retroperitoneal, we'll get some parietal peritoneum onto it. But then the dorsal mesogastrum comes over to the stomach. We have the visceral peritoneum, lesser omentum, and then around the liver as visceral peritoneum. And then half of the falciform ligament. Let me start on the body wall, and the other half of the falciform ligament. Again around the liver, other half of the lesser omentum. Going around the dorsal mesogastrum, Then going around the duodenum, now this again will be parietal peritoneum, and down to the transverse colon, like so. And just continuing around the parietal peritoneum on the ventral body wall, and we've completed the circuit. Now, the lesser peritoneal sac, I'll again color in right here. Again, basically posterior to the stomach and the liver. We'll label some of our structures. Here is the falciform ligament. Right here. The lesser omentum. That would be right here. The dorsal mesogastrum. Right there. And the transverse mesocolon. Which, of course, is the mesentery of the transverse colon. Okay, so this is where our starting point is. And again, the lesser sac you can see is cut off inferiorly, it's blocked, and that's because of the duodenum becoming secondarily retroperitoneal. It seals off this lesser peritoneal sac, or the omental bursa. We'll see in the next video that there is one place of communication between the greater and lesser sacs. That's called the epiploic foramen, and we'll do a diagram at that level. So here we are. Now we're going to form the greater omentum. And the greater omentum is going to form by the dorsal mesogastrum evaginating, growing out. So if we take a look here, we could make the mesogastrum grow out a little, like so. And you notice that would mean that the lesser sac is expanded. And we can take the dorsal mesogastrum and it will grow a little more, so that it is now looking kind of like this. And again, keep in mind, this is all part of the lesser sac that's growing down. And this process continues. Like so. And that lesser sac keeps growing down further and further. And it will grow down over here as well. So what we're going to see is that the dorsal mesogastrum will dip down like so. And we can have the mesogastrum keep growing. We see here, and now you see it starting to take on the form of the greater omentum. Omentum is a term that means apron, and the greater omentum hangs down over our intestinal tract, between the intestinal tract and the ventral body wall, and looks very much like an apron. It is a very fatty tissue, and it looks like it's just some extra bit of tissue that's been left over. That's nothing further from the truth. The greater omentum serves many functions, one as part of the immune system. Now, as the greater omentum grows down, we have peritoneum, sometimes mesentery, sometimes visceral peritoneum, rubbing against each other. And what that will do is cause those areas to fuse together, much like happened with structures that are going to become retroperitoneal. And then the greater omentum, which is mesentery on the greater omentum, which is peritoneum, simple squamous lined cavity on the inside, it will start rubbing together, and as it does, those areas fuse. Same process as we use to get organs to become secondarily retroperitoneal. When we have these peritoneal surfaces rubbing against each other tightly, it will wear away the epithelium and then it will fuse. So I've left this all pretty thick to avoid having to redo the entire drawing. But these areas that you see fused will come down to a pencil thin line, a very thin line of fusion. Same with the greater omentum. So that in the developed embryo, we have the greater omentum, hanging down over the intestinal tracts. Now, also realize I didn't draw in all the small intestine in here because that would just clutter up the drawing. The idea is to see what happens here. The dorsal mesogastrum is gone. And I can erase the that. The transverse mesocolon is originating from the duodenum. Now, so the transverse mesocolon now is roughly in this position. Prepare the drawing here. Transverse mesocolon is here. So the transverse colon still has a mesentery. It's just shifted somewhat. And the lesser sac is, again, in the position we originally had it, posterior to the liver and stomach. And again, developmentally it continues all the way down into the greater omentum, but that area becomes sealed off and adhered. And so in the adult, we no longer have the continuation of the omental bursa down into the greater omentum. And let me add one more label in here just to complete the diagram. The omental bursa, which is the area in pink posterior to the stomach and liver. So you can see how the greater omentum develops, and in the end it's a apron-like structure that runs from the stomach over the transverse colon and then down anterior to our intestinal tract. One should also realize that the greater omentum doesn't just hang there, it can move. It moves slowly, but it does move. And one of the things the greater omentum will do is, if there is a damage to the wall of the digestive tract, the greater omentum will move to that spot and attempt to plug it up. And I mentioned it was part of the immune system. It is richly supplied with lymphatic tissue, and so it also helps fight infections in the peritoneal cavity. The greater omentum can plug up a leaking wall of the bowel. In the next video, I want to talk about the spot for communication between the omental bursa and the greater peritoneal sac. Thank you for your attention.